So this is the first of the macromolecule lectures. We're going to do the 4 macromolecules, so this will be the carbohydrates. But then also we have proteins, lipids, which technically are probably not a macromolecule, and then nucleic acids. So we'll start with carbohydrates. And what we need you to know about this is that the monomer, the subunit is monosaccharide, and monosaccharides are a single segment of sugar. And what you need to know is there's 2 types, the aldehyde sugars and ketone sugars. And it really depends on, again, that functional group and where it's located. So here you can see on the aldehydes, they're at the end, the C double bonded O with an H coming off. And these would be things like glyceraldehyde, ribose, glucose, galactose. And then over here on the ketone sugars, what you're noticing is you have a C double bonded O in the middle. And that would be the ketone sugars like ribulose here. So definitely want you to know those. And then again, they have what they call the hydroxyl group. Okay. So glucose is your typical, and this is the one we're going to be using. What I do want you to know is their molecular formula, which is basically CH and O in a 1:2:1 ratio. So glucose is C6H12O6, and you can recognize the sugar by that molecular formula. And so if you look over here on the left, this is standard how it is drawn, but they're typically in a ring form. This is a lot more stable. And I'm not going to make you recognize these per se as glucose, but I do want you to recognize that this is a carbohydrate with that carbonyl group on the end, and this one is an aldehyde. And they are typically used for energy and storage and structure. And so we'll talk about those. All right, so a disaccharide. What do you need to know about disaccharides? It's 2 monosaccharides put together, 2 monomers attached. And so here I would like you to know that maltose is a disaccharide, and it is made up of 2 glucose molecules. And you can see here when they're put together, you remove water, so it's called dehydration synthesis or dehydration reaction or condensation reaction we talked about before. Here, a glucose and a fructose together will make sucrose, which is a common table sugar. The other thing I need you to know is when they do bond and remove the water, we call that a glycosidic linkage. There's 1,4 or 1,2. These are the sugars that are attached. But I do need you to know the glycosidic linkages. All right, and I did mention earlier that storage is another function of carbohydrates. So what I need you to know is that through photosynthesis, plants make glucose. We're going to do that process for exam 2. But what I also need you to know is when they make extra glucose, they store that as starch. And you can see these starch granules right here. And this is what starch would look like processed. Animals, on the other hand, don't store our extra glucose as starch. I say that in class and people go, oh, I store it as fat. No, actually, short-term storage of glucose actually is converted in your liver into these black spots, which are glycogen. And so that's how we actually store our extra sugar as molecules of glycogen. All right, the other function of carbohydrates is structure, and in plants, that is cellulose. And so what I want you to know is cellulose is in our diet called fiber. We cannot digest this. Actually, cellulose is the most abundant carbohydrate on the planet. And this structure, we do not have an enzyme to break it down. Animal structure, we don't use cellulose. We use something called chitin. And chitin is what you see here. on the exoskeleton of insects and lobster and crabs. And so again, this is the structural. So again, I want you to know that. And here you can see the glycosidic linkage. And the whole purpose of this, again, is to show you that whatever this structure goes to function. So this is not something we're using for energy, but we're using it for structure. And we will stop the share and stop the